Okay, so we're going to go ahead and go through this graphing polynomials activity together. And I know it's homework, but I think it'll be helpful to kind of do it together. So let's take a look at the things that we need to graph these. So once we get things factored, graphing polynomials isn't too bad, which this is kind of the purpose of this activity, is just once you get it factored, how can you kind of easily see the sketch of this by hand? And again, like I said, some classes you're going to have a graphing calculator, and this will feel kind of like why would I do this? And if you don't have a graphing calculator, something like this could be super critical and life-changing. So we're going to all go through it together and, just see how it goes. Okay, so let's take a look at what we're going to do to graph this. So the things we're going to be looking at, and I recommend you don't do this assignment until you've done all the other stuff in this module. So learned all about factoring and some of the terminology here. So I'm going to assume you've done that. And what we're going to need to graph this is going to be, we're going to need to know the zeros. And all of these examples only have these possible zeros or x-intercepts. So these represent your x-intercepts. And we're going to determine their behavior when the behavior of the curve when they go through those x-intercepts. So the behavior could be a cross, a wiggle, or a bounce, and we'll go over what determines each of those. The other thing we're going to look at is the left end behavior and the right end behavior. So does the graph go down to positive or minus infinity for each of these? That'll be what we're trying to determine. The sign of the leading coefficient is, for instance, you look at the very leading coefficient, which is going to be in a lot of these cases a number. So like in the first example, it would be 2. And we want to know, is it positive or negative? Because that'll help us determine the left and right end behavior. And we're going to need to know the degree. The degree is, what's the power on the leading term? So the degree, we're going to multiply all the biggest terms of the factors to get that. So let's just write for degree the power of leading term. And in parentheses, expanded. So the notation's given to us in factored because it's easiest to graph, but in our head we can kind of quickly figure out the leading term. So what we're going to do is we'll use the sign of the leading coefficient and the degree to help us figure out what's the left and right end behavior. So I'm going to try and teach you guys how to do this fast as possible. Okay, so the last thing we need is the whole cross, wiggle, bounce. Let's go ahead and go over what makes something cross, wiggle, or bounce. So a cross is going to happen when your zeros have multiplicity 1. A wiggle is going to happen when the multiplicity is 2, 4, a wiggle is going to happen when the multiplicity is 3, 5, 7, all the odd numbers, so on. And a bounce is going to happen when we have multiplicity 2, 4, 6, 8, and so on. So only one of those things can happen at a 0, and it's going to affect how we draw the curve going through them. So the picture shows how we would draw the curve. So for instance, when I say multiplicity, I mean what's the power on each factor. So let's go ahead and go through and do the multiplicity on the zeros for number 1. So our function is 2x to the 4th times x minus 1. And when we look at our zeros, let's match which ones we have. So for this first example, there's x to the 4th. That goes with the 0, x equals 0. I can tell because I set it equal to 0, I solve, and I get 0 back. Okay, now we'll go through and we'll do the same thing for x minus 1. We'll set that equal to 0, and that goes with x equals 1. Okay, so this one doesn't have a 0 of -1, and we'll cross that out. So these two are not applicable. Now we need to write the multiplicity that goes with 0. So the multiplicity for 0 would be 4 because that x factor is raised to the 4th. And the multiplicity for 1 would be just the power 1 because nothing is written. Okay, so now we're going to determine what the curve is going to look like at 0 and 1 by comparing these multiplicities with the behavior. So cross would happen when we have multiplicity 1, and for multiplicity 4, that's going to be a bounce. So I'm looking at these numbers here, 4 and 1, and I'm comparing those with the cross, wiggle, bounce multiplicities. That's kind of where I'm looking. Okay, so we kind of have an idea there of what happens at the zeros, but we need to know the end behavior. So I kind of recommend doing the sign of the leading coefficient and the degree first, personally. So the sign of the leading coefficient is not too bad to find. The leading coefficient is this leading factor number out front. It's going to be 2. So the sign of that is just positive because it's a positive 2. And the degree is going to be what is the power on the biggest x, let me rephrase. If I expanded this out in its multiplied form, what is the power on the biggest, what's the biggest power of all the terms? So when I multiply x to the 4th times x, that gives me that the leading term, and times the 2, the leading term is going to be 2x to the 5th, so the degree would be 5. Okay, now when we think about a 5th degree polynomial, what we can do to kind of help us figure out the left and right end behavior on this is we can imagine our leading term, and we can plug in a negative x value and a positive x value. Okay, so I can already tell you that this one's going to be really big when I say this one. I can tell you that when I plug in negative 100, that's going to be a really large negative number, so it's going to be like, negative 1,000,000 times 2, so it's going to be negative. So that means the end behavior is negative infinity. Versus the right end behavior, we've got a positive 100, so positive infinity. Okay, so with that picture in mind, it's going to go down to the left, up to the right. Next, we plot our zeros. So our zeros were 0 and 1, and we're going to connect the dots. Okay, so I'm going to start with the arrow. I'm going to start on the left-hand side, and at 0, I'm supposed to bounce. So I bounce at 0, I bounce off. Then I come up, and I'm going to cross. I'm going to cross through. So I didn't change my curvature at all as I went through 1. Okay, that's what this graph has to look like. And you guys can confirm on your graphing technology, like, am I doing this right, basically. So that's our graph. Okay, and we're going to keep working some examples. Okay, I know this is going to be like a process that like takes a little bit just to get used to. So let's go through and match our zeros. So we've got the factor x and the factor x plus 1. So this is going to be 0, this is going to be x equals negative 1, so there's no 1, so this column is not applicable. And then for negative 1, the multiplicity is 5, and for 0, the multiplicity is 1, so that means now we can determine our wiggle cross bounce. If the degree is odd, that's an example of wiggle. See, multiplicity 5, odd, versus multiplicity 1 is an example of a cross. Okay, so now let's figure out the leading term, because that's going to help us complete all of this stuff on the right. So the leading term is going to be you take the leading terms of each factor and multiply. So negative 6x times x, but then don't forget about this power to the 5. So the leading term of this, when we fully expanded it, would be negative x to the 6th. Okay, so now we can fill out that the degree is going to be 6. The sign of the leading coefficient, well, it's a negative 6, so it's going to be negative. And then when we do our end behavior, you guys are going to rapidly start to see some patterns emerging here. When I plug in a really big negative number, that gives me a negative times a really big positive. So this is going to end up being a negative infinity. And when I do a positive large number, I'm going to get a negative times a positive. So that's going to be, again, negative infinity. So the left end behavior is down to negative infinity. The right end behavior is down to negative infinity. And our zeros are at negative 1 and 0. And I'm going to start from the left. I'm going to wiggle through 1, so I'm changing my curvature. Changed it from like a frowny to a smiley, aka concave down to concave up. and then we're going to come around and cross through at 0, not changing the curvature at all. Okay, so there we go. Now let's go ahead and move on to the next one. So looking at my factors, looks like I've got 3 factors now, so that's a little fun. X minus 1, and x plus 1. So my zeros are 0, 1, negative 1. And we've got multiplicities. For 0, we've got multiplicity 1. For 1, that's the purple or the blue. For 1, we have multiplicity 3. For negative 1, we have multiplicity 2. Okay, so just making sure that we matched these. Negative 1 goes with 2, 1 goes with 3, 0 goes with 1. So then that would mean that at negative 1, we have a bounce because the multiplicity is even. At 0, we have a multiplicity of 1, so that would be a cross. And at 1, we have a multiplicity of 3, so that would be a wiggle. Okay, so now I'm going to go over here and graph these. We got negative 1, 0, and 1. Okay, so moving through this, we've got, let's figure out the end behavior and the leading term. So the leading term here, we're going to take the leading terms of each factor. Don't forget about the exponents. So the leading term will be 3x times x cubed times x squared, which is going to give me, I guess that would be total degree of 1 plus 3 plus 2, so 6. So the leading term is going to be 3x to the 6th. And then the degree would be 6. The sign of the leading coefficient would be positive because the 3 is a positive number. And the left and right end behavior we'll figure out by just plugging in some x values. Okay, so I'm going to plug in negative 100 and positive 100. You guys starting to see the pattern here? We have a positive times a positive number, so it's going to end up being positive infinity. And we have a positive times a positive, so that's going to be positive infinity. Okay, so if you're kind of thinking, well, why did the negative 100 to the 6th turn positive? When you raise a negative number to a positive power, it means you have 6 negative 100s times each other. And that would mean that they pair off, negative times negative, giving you a positive. So that's why the evens always lead to positive infinity. So you guys notice something. Hopefully we can start seeing a pattern here. When we had an odd degree, the end behavior, so let me point to an example. When we had an odd degree, the end behaviors did not match up. When we had an even power, the end behaviors did match up. Okay, we still have to figure out what they are, but it's helpful to kind of know those patterns in the back of our minds. So end behavior of both of these is positive infinity, and I'm going to start from left to right. At negative 1, I should be bouncing, so I'm going to come down and bounce off. And then as I go through 0, it's going to be a cross. And then as I go through 1, it's going to be a wiggle. So it's going to end up being shaped like a U that then kind of wiggles. So just make sure you change the curvature, and you know, the exact arrows that you draw on the start, like these ones, they're just guidelines, guys. Don't feel like you actually have to connect the dots with those. These sketches are very quick and they're not precise. The only way to get them precise is going to be a skill you guys learn in calculus to actually figure out the exact like turning points, the actual minimums and maximums and all that. That's a very cool calculus skill you guys are going to get. Okay, so let's move on. Okay, so let's take a look at number 4. We've got our factor x. So that goes with the 0, x equals 0. It's got multiplicity 1, and so that's going to be a cross. Now let's do the x minus 1 factor. That goes with x equals 1, and we've got multiplicity of 6. So that's going to correspond to a bounce. Now we're going to go on to the x plus 1 factor. That corresponds to x equals -1, and it has a multiplicity of 7, so that's going to be a wiggle. Okay, let's get our leading term. So we've got -5x times x to the 6th times x to the 7th. So leading term would be -5x to the 14th. So that would be degree 14. The sign of the leading coefficient is negative because the 5 is negative. And then for the left-hand behavior, we're going to plug in a value to the leading term. And really quick, we know that that's going to be a negative times a positive because you're raising the -100 to a 14th power. So negative infinity. And based on the pattern we were just talking about, we already know the next one should also be negative infinity, but we'll see. So when I plug in a positive 100, I get a negative times a positive, which is going to be, again, negative infinity. So the end behavior is going to look like that. And our zeros, we're going to have -1, 0, and 1. And we're going to start off with a wiggle through -1. Okay, so change the curvature. Then we come through 0, add a cross. Then we're going to come off 1, add a bounce. There we go. So these polynomials look kind of cool, look kind of weird. Okay, let's move on to number 5. So hopefully you guys are pausing and taking seconds to digest. I'm not going to edit that into this. I'll just let you guys kind of move at your own pace because I don't want to make the video too slow for you by rambling and pausing a lot. Okay, so let's jump into number 5. We've got here's my factor that goes with x equals 0. So the power on that is 2, so we've got degree multiplicity 2, and that's going to be a bounce. On the x plus 1 factor, that goes with 0, x equals -1, and we've got a power of 3, so that's going to correspond to a wiggle. And then we have x minus 1 to the 4th goes with 0, x equals 1, and that's going to be degree 4. So the multiplicity there is 4, and it's going to be a bounce because 4 is even. Okay, and then let's get the leading term. We've got -5 times x squared times x cubed times x to the 4th. So that's going to be 2 plus 3 plus 4 gives me 9. Yeah, 7 plus 9. And then the degree is 9. The sign of the leading coefficient is negative. And when we do our check for the end behavior, we've got -100 raised to the 9th power. That is a negative times a -5 gives me a positive, so it'll go to positive infinity. And when we plug in -5 times positive 100, we've got negative times positive, which gives me a negative infinity. Okay, so then we've got left end behavior is positive infinity, right end behavior is negative infinity, and as we go through -1, we're going to wiggle, so change the curvature, and then off of 0 we bounce, and then off of 1 we also bounce. Okay, so hopefully you guys are seeing that once you have these things factored, graphing them and at least getting an idea of the shape is not too bad. The only thing these sketches really aren't telling us are the local mins and maxes, which, like I said, we're going to figure that out in calculus. Okay, let's take a look at number 6. We've got here's our x squared factor that goes with x equals 0. Let me shrink this a little bit. Okay, so the multiplicity on x equals 0 is 2, which is going to correspond to a bounce. The multiplicity on x equals 1 is going to be a 5, and that's going to be a wiggle. The multiplicity on x plus 1 is 1. So the 0, x equals negative 1, has multiplicity 1, and that's going to be a cross. Okay, and then getting that leading term, we have 4x squared times x to the 5th times x to the 1. So that's going to be 4x to the 8th. And so the degree is 8. The sign of the leading coefficient is positive, and the left end behavior is negative. Thanks. A little bit on autopilot there. Let's check it. 4x to the 8th, 4x to the 8th. So when we plug in negative 100, we have a positive times a positive gives me positive. When I plug in 100 here, I have a positive times a positive gives me a positive as well. So our end behavior is going to look like that. And negative 1, 0, 1. As we go through negative 1, we cross. So no change in curvature there. Okay, then as we go up to 0, we bounce. And as we come through 1, we wiggle. Okay. Let's do the next one. We have y equals 200x squared times x minus 1 to the 5th times x plus 1 to the 6th. So for the 0, x equals 0, we have degree of 2, which corresponds to a bounce. For the 0 of 1, we have multiplicity 5, which corresponds to a wiggle. And for the 0 of x equals negative 1, we have multiplicity 6, which corresponds to a bounce. Okay, and then let's do our leading term. We have 200 times x squared times x to the 5th times x to the 6th. So that gives me x to the 13th. Okay, so we have degree 13. Sign of the leading coefficient is positive. And then checking the end behavior, when I plug in a negative 100, I have a positive times a negative, giving me negative infinity. When I have a positive 100, I have a positive 200 times a really big positive number. So the end behavior there would be positive infinity. Okay, so now I'm going to draw the end behavior. It should be negative infinity to the left, positive infinity to the right, and the zeros, we've got negative 1, 0, and 1. We're going to come up starting left. We bounce off of negative 1. And then off of 0, we also bounce. And then through 1, we wiggle. Okay. Okay, so I don't know why the questions went a little out of order here. I think they thought maybe like these were harder, but basically we're going to practice going the other order with these, and then we'll kind of answer those conceptual questions about patterns that I was pointing out. So let's take a look at what our graph looks like. Looking at this graph, they kind of filled in some details. They said, okay, at x equals negative 1, you can kind of see the wiggle there, and they were just pointing out at 0, you can see the bounce. And as you can tell from this graph, it doesn't cross at x equals 1. So just kind of emphasizing it so you can see it a little better. So we're going to use this information to write an equation. So I know for a fact that I know the multiplicities. So if we have, looks like they did it the other way, so they have wiggle and 5. This tells me that the power that goes on x plus 1 should be 5. X equals 0 should be 4, so that means we should have an x to the 4th. And then we don't have any more factors. So the only thing we have to figure out is, okay, could there have been some sort of number out front, like that was making this positive or negative? Is this what we would expect? So we're not quite ready to fully fill in. Like, you won't be able to know exactly what number that is, but you'll need to either put like a positive or a negative one. So based on what we know about this function, I know that so far the leading term is going to be something like x to the 4th times x to the 5th. So it's going to be a degree 9. Okay, and because the end behavior is to the left is negative infinity and to the right is positive infinity, that means that it's kind of exactly, basically this wouldn't be multiplied by anything other than a positive number. If I tried to multiply out front here by a negative, it would switch that end behavior around, because if I tried plugging in a negative number to x to the 9th, you should get a negative. If you tried plugging in a positive, you should get a positive. So the sign of the leading coefficient must be positive. Okay, so we're done. We're done. We don't need to, we'll just say positive. Some sort of positive number would go there. Okay, let's try that again. So if I've got, looks like all three of my zeros are represented here, and it looks like at -1 we are crossing. So in order to have a cross, your multiplicity would have to be 1. Okay, and that allows me to write my formula. So x plus 1 should be to the power of 1, and x should be to the power of 6, and x minus 1 should be to the power of 1. And then we have to figure out, okay, is it going to be a positive or a negative? We're not sure yet. So the degree on this would be x times x to the 6 times x. So x to the 8th, degree is 8. And the end behavior based on this graph is that we've got positive infinity, positive infinity. So that's what we expect for an even-powered function. Like if I try plugging in -100 to the 8th, it checks out. And if I try plugging in 100 to the 8th, it checks out. So it must be, again, that the sign of the leading coefficient is positive. So we'll just put a positive in there. And it could be any number, but that's not really the point. We're just trying to figure out generally what, formula this would be. We wouldn't be able to figure out that number without a lot of calculus and advanced math. Okay, so this next one, number 18, they're giving us a real challenge here. They're only going to tell us the multiplicities and the end behavior. So down, down, I prefer negative infinity, just be a little more precise with your language. So negative infinity, and at -1, we're going to have multiplicity 4. So x plus 1 should be to the 4th, and that represents a bounce. And at x equals 0, it should be to the 7th, and at x equals 1, we should have multiplicity 1. So that would be our formula. And then the multiplicities would be at 7, we're going to wiggle. At 1, we're going to cross. Or not at 7. At 0, we're going to wiggle. And at 1, we're going to cross because of the multiplicities. Okay, so I can sketch that now. So at -1, we're going to bounce. 7, we're going to wiggle. Try and reflect that wiggle there. And then at 1, we're going to cross. Okay, and then based on the fact that the end behavior is negative infinity, I think we're going to need to have a negative out front, but let's check it. We got x to the 4th times x to the 7 times x for our leading term, and there may be a negative number out front, so x to the 12th. So degree is 12. The sign of the leading coefficient, we don't know that yet. That's going to be the last piece of this puzzle. So I'm going to check the end behavior. X to the 12. If I plug in -100 and raise that to an even power, it would have to be positive infinity. But because this one's negative infinity, that must mean we in fact do have a negative out front. So that tells me, okay, we need to have a negative number out front. So we'll just put a -1 for now, and we'll check, does that also make the right end behavior negative infinity? It would appear that it does. Okay, so let's take a look at those, just kind of summarizing up patterns and things that we were observing here. And this may or may not help you. Sometimes shortcuts, people find those more or less helpful. Okay, what do you notice about the exponent on the factor in each equation when it bounces off of a 0? Even. Okay, we already pointed that out. When something bounces, it's because you have an even multiplicity. Okay, what do you notice about the exponent on each factor when the graph wiggles? Okay, it should be 3, 5, 7, 9. It should be an odd number bigger than 1. What do you notice about the exponent on the factor in each equation when the graph crosses? It was 1. Okay, describe the end behavior when the leading coefficient of an even degree polynomial, so an even degree polynomial, is positive. So the leading coefficient, so that's saying that you have a positive, let's look at an example. It's saying you've got a positive and an even, so it would be like this one. Okay, it looks like the end behavior is positive infinity and positive infinity. Okay, describe the end behavior when the leading coefficient of an odd degree polynomial is positive. So odd degree, but a positive. So here's an example of that. Positive and 13. We got positive and an odd degree means that the left is negative, the right is positive. So it would be negative infinity left and positive infinity right. Okay, describe the end behavior when the leading coefficient of an odd degree polynomial is negative. So an odd degree polynomial is negative. Okay, so there's the odd, so it looks like the left end behavior was positive infinity. While the right end behavior was negative infinity. Okay, and then let's describe 2 ways you can find the degree of a polynomial given the equation in factored form. Okay, so here's what I was doing. I was writing out the product of lead terms of each factor. So for example, we did like x to the some number n times x to the m times, we did this work right here. Okay, that's one way. The other way is you may have noticed there's a shortcut, which is notice that our powers added up. So the powers 4 and 5 added to the 9. Okay, we're just kind of saving a little bit of time. So adding multiplicities would do it for you. Okay. Whew. So like I said, I didn't want to do too much small talk and drag this out. Oh, we forgot to write down something here. Describe the end behavior when the leading coefficient of an even degree polynomial is positive. Oh, I think this one, I wrote this in the wrong slot. This actually goes here, and then this should be negative infinity left and right. Okay. Okay, so in any event, hopefully with a little bit of practice and maybe some clarifying questions from me, that hopefully makes a little bit of sense, but pretty quick process. And this is just the kind of thing where when you're trying to get a quick sketch in your mind for calculus, it's really nice to kind of have this knowledge and background, particularly like I said, if you're going to some place like Cal Poly where they take away your graphing technology when you're in class and on exams and stuff, having these abilities to get sketches in certain problems is really necessary and helpful. So this would be how I'd quickly get that. Anyway, I hope this helped you guys, and see you next time.